All right, hopefully I have audio. Okay, yeah. So I don't know, something weird going on here where I have to fix my audio as we're starting this semester. Hello? Okay, thank you, Moretta. Appreciate that. Yeah, so I'll just say that right up front. I really enjoy having people here for the live stream. I know not everyone can make it. Sometimes you have to come late and leave early. Sometimes you can't make it at all and you watch the video later. But if you are here, I very much appreciate it. I'm glad that I see that there's a bunch of you here today, a bunch in terms of the audience I attract in my streams. But it's very useful if you let me know if my audio's off or if I'm talking about something and I forgot to switch the view on the screen so I'm talking about something and you can't see it. So anyway, it's nice to have you out there and it's nice to get the help that no doubt you'll render for me on occasion. Okay, so cool. So Moretto will be able to, hopefully I'm saying that the way you would have me say it. We're able to make it most of the time, so that's awesome. I'm glad to hear that. So who I can see in my software is not as many as are here, I don't think. So I can see Magenta, which, welcome back. I saw you yesterday. Casino, Adisha, Lou, and 420. So hi to all of you and hi to everyone else if I can't see your name. And hello to you if you're watching the video later. So this is Isnam. Nice to see you. Hello. So this is CSCI 10, Computer Architecture and Organization. What you're looking at on the screen shows a control number of 2465. But we added a second section and I'm teaching both of them because we know that for pretty much everybody who takes this class, this is either you are at a point of completing your program for a degree or a certificate or transfer, or you are very soon to be where you will be completing your program. So we're not offering this course in the spring, so I took on an extra course. So anyway, you'll see that the number may not match your control number, but our schedules are the same. I'm going to do one live stream for both classes. Your assignments are separated and your discussion groups are separated, but in terms of what you'll get from me on the video and the live stream, and the content and the schedule, all the same for everybody. Um, all right. Nice to see you, Adeline or Adolin. Glad to have you here. Anyway, so don't worry about the control number. This is the same content, same scheduling, everything for both sections of CSCI 10, Computer Architecture and Organization. So I'm Boyd Trollinger. My full name is John Boyd Trollinger. So when you see my email, it will say Trollinger, J-O, but I go by my middle name, Boyd. So that's why that doesn't match. So what was my plan of attack here for today is I'll show you how the course is set up in Canvas. If you have another class with me, hopefully you don't get sick of me, but you'll see the same organization. I use it in every class, but not everyone has another class with me. So we'll walk through the way I set up the course in Canvas. We'll stop and spend time on the syllabus so that you know how what the expectations are in terms of your work and where grades are earned. We'll take a break, and then we will deal a little bit with the sort of lecture content of this first week, and then we will spend some time with me doing a demo in our programming environment. So yeah, that's the plan of attack. I think some of you have already started. You've downloaded the virtual machine, and I know some of you are encountering hiccups here and there with that. So I'll try to give you the tips that I know to share with you to try to make that easier for you. But anyway, that's after the break, later on in the live stream. We'll get to that. Okay, so let's go through the course as it looks in Canvas first, just to get that out of the way. So this is the course homepage. This is where you're brought when you click through from the dashboard in Canvas. And I tried to put everything that you could need most of the time. Like this is, I hope, a good starting point for whatever it is that you want to do related to this class. So announcements, as they do in Canvas, appear at the top. I don't create that many announcements. The announcement that's there right now is just a reminder that I would hope most of you would see that we have this live stream every Tuesday afternoon from 1 to about 2:30. Sometimes I don't need an hour and a half to get through the content. I leave a little bit of space on the other side of 2:30, meaning I'm willing to go longer if there are people in the live stream asking questions, or I have had questions communicated to me that I need time to deal with. But typically that's about an hour and a half is where I try to fit the live stream into. If you have to come late or leave early, that's fine. The video will be made available. Usually I try to get the videos processed and linked up everywhere immediately at the end of the live stream. So here on the homepage, announcements, and then this top section is all of the sort of the main ways that we keep in touch with each other during the semester. So the live stream every Tuesday, barring some unusual incident, every Tuesday from 1 p.m. to about 2:30 p.m. I also use, let me see if the numbers match. Okay, they do. I also use Confer Zoom, which I'll show you here in a moment, which is a way for you to reserve one-on-one time with me. And I'll show you that here in just a moment. But I do office hours on Thursday afternoons from 2 to 4 p.m. Is scheduled one-on-one time. That's what Confer Zoom is for. And then I also do a drop-in office hour from 4 to 5 on Thursdays, where I just open up Zoom and I'm sitting there and you can come, and sometimes a handful of people will come, sometimes nobody comes, but that Thursday afternoon hour is there so that you don't have to schedule. If you just have a question or have something you want to talk about and you didn't think to book Confer Zoom time, you can just drop in. So that's another way to sort of keep in contact with me, is Confer Zoom. And then the next one after that is the drop-in office hours and a link to the Zoom meeting room. And then finally, if no other mechanism is working for you to get the help or the time that you need to ask questions and have them answered, then you can always contact me through the Canvas inbox, and we can arrange a specific time that works better for your schedule. So yeah, that's the ways that we keep in touch with each other. We also have a discussion forum, which is another way we can keep in touch with each other. But the discussion forum is open to everybody, so those tend to be discussions where we ask and answer questions among ourselves that we would like everyone to be able to share in the answers. Okay, below that is a weekly schedule for the whole semester. So if you're ever in doubt about what you should be doing with yourself in a given week, just come to the home page, scroll to the bottom, there's a schedule. It links to all the content, that's what the modules are. It reminds you when the big projects are due. And so this should be a place where you can go and find your way to where it is that you want to be in any given week. We don't do exams, I don't do quizzes. We have enough work just in the weekly work that we do, and then I have these slightly larger projects that you work on individually, where you can bring together a whole bunch of concepts in one place. They are writing software, programming, in other words. Okay, so there's that. This week is the one week that's a little bit different because there is a week 0 module, which is an orientation, which before I take a break, that's where I will go last. And then we also have the first content of the semester, which is the week 1 module. So I'm not going to click on those yet. I'm going to go through the other links in the Canvas course, and show you what those are before I come back and walk through the week 0 module. The view I'm using here, by the way, this is my instructor's view. The reason I use this view, even when I'm talking to you, is that even though I know you see garbage that you wouldn't see in your own Canvas view, but things like Confer Zoom don't work if I'm not using my instructor view, and I want to show you that. So that's why I'm just kind of letting you see all the garbage. I won't go anywhere where there's any personal information showing. It's just the content pages. Okay, so the next link after that is announcements. I rarely use them. I can't imagine a situation in this class where I would use them. But if an announcement should appear, then it's probably something unexpected has occurred. So I'd encourage you to go look if an announcement should appear, and make sure that you are keeping up to date with what is going on in the course. I don't anticipate anything. The only thing that once in a blue moon happens is that I change a deadline for something, but the deadlines always get pushed to later and not to earlier. So there won't be any surprises, barring the unforeseen, but there shouldn't be any surprises in terms of your work in the class. The next link after that is the modules. So this is the entire content for the entire semester. I do not hide the content from you. So the entire semester's content is posted. Every module after the orientation module has the orientation as its prerequisite. So I do require that you complete the orientation module so that I have some assurance that you are aware of the major course policies before you begin to do other work in the class. But beyond that, you'll notice that every module has as its prerequisite the orientation and nothing else. So you can look around all you want to, all the content's there. If you are the type of person who likes to work a little bit ahead, you can certainly do that. That's rare in this class because the material is so new to most people. But I'm not hiding anything from you. So if you want to look, it's all there for you to browse through if you would like to do. The main thing, of course, is to not lose track of what it is you're responsible for this week and next week and so on. Okay, so Confer Zoom. So this is where, if you want one-on-one time with me, this is where you would go book that one-on-one time. So you'll see something similar. And again, I have the instructor's view, but you will see something similar in here that's showing you the blocks of time that are available each week. I have cut them out to be 15 minutes at a time. So notice somebody in one of my classes is booked some time, and possibly two people have booked some time with me this Thursday. So this is where you can book one-on-one time with me. If you find all the slots are taken, which would be unusual, but if they are and you need to meet with me, then please use Canvas Inbox to contact me. So let's confer Zoom. Water. Ooh, I'm up to 15 people. Let me go down and say hello to people. So, hello, 420, Dolan, Akawe, Alua, Disha, Casino, Emberwolf. I think we talked yesterday, didn't we, Emberwolf? Fezboy Isnam, Jimawu, Linkridge, Magenta, hello again, Moretta, that one kid, I think I saw you yesterday, and also the moderator, I saw you yesterday as well. So, I hope that you don't come to think, oh, woe is me, I have to see this guy twice a week, every week for 17 weeks. I hope that it's at least time that you think it's worth spending, because you're learning something at least most of the time. Of course, my dream would be all the time. So anyway, hello to everybody out there. What was I doing? Oh yeah, I was talking about the class in Canvas, but I noticed that the number of people I can see went up, so I wanted to say hello to a few more. Okay, so now I am on the guides page in Canvas. Just checking to make sure you can still see what I see. You can. So these guides, these don't change. What they are, though, is they are, I'll show you one just as an example. They are meant to walk you through some of the major tasks that you need to be able to complete to do labs and projects in this course. Let me just show you one as an example so that you can see what they're like. These guides are linked in a variety of places, so you'll see links to the guides in the lab. Sometimes you'll see a link to some of these guides in your projects sometimes. But I also just made a separate page for them, just in case you were thinking, like, how do I do this major task? I don't remember. Here's what the guides look like. And these are all fresh, meaning that I redid these last week for the current versions of things, I think. Yeah, I did. So what the guides are, they're simply step-by-step instructions with pictures from my screen, and sometimes I sort of marked up the picture to draw your attention to things as you're working through. So hopefully these guides will help you not be stuck, at least on some of the major tasks for the course when you are at home alone doing work. If you ever are stuck, by the way, we have a discussion forum, which I'll show you here in a bit. Canvas Inbox, office hours, drop-in office hours, the various ways that you have to get in touch with me if you do feel like you're stuck, and I will do my best to, and hopefully succeed in getting you unstuck. Oh yeah, that's true. So I'm just sort of looking at comments. So oh, that's cool. So that one kid, someone recommended it. Hopefully maybe it was partly me in the course also, but hopefully I can make value of the course for the time you're spending in it. And I noticed a lot of familiar names from P&A too, and probably a lot of you know each other from other instructors, Programming Algorithms 2 classes as well. Okay, so there's the guides. Got their own page, but most of the time you'll find that assignments link into these guides when I think that it might be helpful to you. Okay, so videos next. So the videos page is not populated because I haven't made any videos yet this semester, but what happens is at the end of the live stream, when I shut down the live stream every Tuesday, Twitch will keep a video of the live stream for me for I think like 60 or 90 days. So you have Twitch always for videos of the live streams if you like Twitch as a channel. Inside of Canvas, I also export the same lecture video over to a YouTube channel and link it here. And I also send the video for captioning with a service that the college uses. And then I link that sort of officially captioned video onto the videos page as well. And then I put a description in the topics column about what I talked about that day. So hopefully you will find that it's easy to locate the lecture videos when you want or need to see them. Oh, thank you, Moretta. I appreciate that, recommending the class to other people. I think if you've known me over maybe the past 4 or 5 years, I think maybe I've gotten a little bit less gruff. I sound terrible, but that's because my voice is out of shape. But maybe I'm a little bit more laid back. I don't know. You'll have to be the judge. So anyway, that's the videos page. I just want to make it so that you have these variety of ways that you can get at the lecture video. So if you like YouTube, you can do it there. If you like Twitch, you can do it there. If you'd rather access it here through Canvas, it will be here as well. There's one other place that we'll come across here in a moment where you will also find my videos. The grades page, which will have your grades on it. And then the last will be the syllabus. Yeah. So just before COVID, I was probably pretty anxious and uptight still. But I've tried to make good use of the time where I've been forced to stay in my home to be more relaxed. Okay, so the syllabus. So this is where, for some of you, this will be sort of some of the more important stuff we do before we get to content, which is how are grades earned in this class? What kinds of activities do we do? How often do we do them? That kind of stuff. So computer architecture and organization is... it's a bit of a one-off class in terms of the computer science sequence because most people won't find themselves directly using this assembly language class's concepts. At least you won't be conscious of it later in your academic and then your professional career. But there are lots of things that are super, super useful to know from this class, and you will find yourself using them if you learn them. Knowing how integers are represented on a modern computer processor, you will use that information. How the hexadecimal numbering system works, if you know it, you can use that information much to your advantage, and you will discover that lots of other programmers actually use it as well. I also try to create opportunities where you can sort of grow your confidence in your ability to express your ideas as a computer programmer. So we do write a lot of software in this class. And a lot of that is because I want you to grow. I want your confidence to sort of settle in and you feel the power that you have when you're sitting at the keyboard. I'm seeing in the chat, some people are getting a little bit of bumps in the stream. I wish there were anything I could do about that. Yeah, so Linkridge asked, can I edit old Sega games? And I would argue yes, because likely what you would do with an old game is you would open up the binary in a hex editor and you'd go poking around for the interesting things that you could find and do in the actual binary of the original game. And you will learn what the meaning of many of those things are in this class. Okay. So there's my pitch for the class. I do think it's worth it. I do think that the opportunity to practice your programming skills can be useful. And I do think that kind of understanding how computers represent data, how decision-making and looping actually are executed on a modern processor, those things are very useful when you're writing high-level software. Okay. Course materials. So I'm just going to go down through course materials. I don't have people buy books in any of my classes. I use an online book called The Art of Assembly Language Programming, and you will find links to the relevant chapters in each week's content module. It turns out that if you want a paper copy of this book, you can find them online. There is a publisher. I don't even think I link them anymore, but you can actually, if you go Google this, you can find that there's a publisher who sells a paper copy of this book online if you would like to have that, but you don't need it. I just linked to the individual chapters. We also need some software, which I know some of you have already begun to set up and work with a little bit. They're free software, but we do use a virtual machine in this class. The reason why I do that is because it allows me to install all the software that you need for you so that you don't have the hassle of trying to figure out how to install it for yourself, because for a lot of people, the installation of our programming tools is not a straightforward thing. Yeah, so there's that. And then finally, we use the Piazza discussion forums, which is a separate website. You will create a free account for yourself there. I like Piazza because it lets you remain as anonymous as you'd like to be. You can literally choose to be anonymous when you post, or you can at least replace your real name with a tag if you like. But still, I as the instructor can see who you are so that I know when you're contributing, and I can keep track of your activity in the class. So that's a free account, but that is where our class discussions will happen. I like this class discussions in this class. Is one of my favorite classes to do discussions, because it's a place where we can go out and do a little bit of research, take advantage of the skills and knowledge that you've already acquired working through your program, and kind of do more and bigger things as a group. Okay, so that's the materials part. Course requirements. So these are the activities that you do for points that ultimately lead to a semester letter grade. We have the one quiz this week. It's the orientation quiz. It's the only quiz you'll ever see in this class. It's the only thing that looks or feels like an exam at all, I guess. And it's just there to assure that you have encountered the major course policies. We do have a homework, and the homework consists of, I think for your class, I decided to go with like 10 questions a week, roughly. But anyway, you get a set of questions every week that's associated with a reading that I've asked you to do. They're all multiple choice, and they are there so that you are encouraged to do some preparation. And also because some of the learning we do in this class is not best learned by creating software. Some of the learning we do needs to be encountered sort of in traditional book form, or by working problems that look like math problems, that kind of stuff. So there are 17 homework assignments. I keep the best 15, and I'll come back to that idea in just a moment. So there's a homework assignment every week, but I drop the low 2 scores, which can also be zeros if those happen to be your low 2s because you just didn't get to it or didn't want to do it some week. We also have a lab assignment, which usually involves a small amount of programming. We have a lab assignment with a small amount of programming every week for 17 weeks, and I keep the best 15 scores that you get. Discussion. So I give you a discussion prompt, a question or an issue to work on as a group, and we do a discussion prompt every week for 17 weeks, and I keep the best 15 of those. I know discussions in an online class, they seem perfunctory and they seem kind of tiresome and boring, but it's one of the easier ways, I think, that we can at least remind ourselves that we're not alone in any of this, that we have classmates around us, that we are thinking about the same things in this class and working on the same things in this class. It's a way that we can just pose a question, and our classmates and me, the instructor, can join in working toward a solution together. Okay, we'll get to that. There's a couple of questions in chat about what kind of programming we're doing. So we're using a sort of a highly specialized programming language in here, and I'll describe it in more detail when I get to looking at the lab itself. The language we use is called High Level Assembly, or HLA. So if you're Googling HLA, Google HLA space assembly, because there are other HLA things in the world. I've actually in my career worked on a simulation framework that was called High Level Architecture, which is not what we do in this class. So the language is called High Level Assembly, or HLA. And we tend to write small programs that let us experience either features of the computer processor, like the way that it represents data, or the way that we do decision-making logic, or at least the way the processor manages decision-making and looping logic. Occasionally, I'll have you do little bits of programming that remind you of sort of common algorithms that are nice to practice. That kind of stuff. Usually, I will give you a sort of a starter code and ask you to go either change things or add things to it to make it complete. But you'll see an example of that today. Okay, and then individual projects. So these are what you have likely encountered in your career at this point, which is a slightly larger programming assignment. It will use the HLA language, and it usually is expected that it will take you some process of working over a number of weeks to solve it as you learn more of the bits and pieces that you need to solve it. So there's two of them. I would argue that I think most of you will find that they are not very large for where you're at in terms of your skill level. So they're not meant to kind of force you to be a better programmer. They're just meant to be a place where I can get you to bring together the various concepts that we've been studying and use them all in one place at one time. Okay. Course policies. It's kind of boilerplatey, this course policies. The individual projects, there's two, and that's just it. There's no throwing out any of them. So you do two, and the points count toward the final grade. So participation is a good thing. Being here at the live stream, if you can pull it off, that's terrific, because I think it makes even the videos better if I'm responding to questions and comments in chat. So if you can find time in your schedule to do it, it's super, super helpful for making the stream a little bit more lively for the people who are watching the video later. And also it gives you a chance to ask your questions and have them answered on the spot. But the other ways that you participate are, of course, by turning in your work, but also by going into discussion, reading what your classmates have to say, attempting to help them solve their problems when you have time to do it, and keeping in touch with me should anything sort of unusual happen, just so I know you're out there and that you're progressing, that kind of stuff. So there's a question in chat about, could you take this class with no programming experience? Technically you could. Our system won't allow it anymore because I don't teach programming in this class, so I expect that you already know what I mean when I say I/O, what I mean when I say arithmetic operators, what a loop is, and you have a sense of different kinds of loops without me having to teach them. You know what a function is, you know what a struct is, or something similar to a struct like a class, and you know how decision making is done in some high-level language. So the reason why you have to have at a minimum P&A 1 to be in this class is because the class from day one expects that you know all of those things I just listed, that you're familiar with them in some programming language, because we don't have time to teach programming. All we do is sort of have, in this class, is we peel off the layers of high-level programming to see what's happening underneath. So that's a good question. It's not equivalent to C or C++. It is C-like. Probably most of you have never seen Pascal, but HLA is a very C-like language, and it's also got elements of Pascal in it as well, interestingly. It will be very familiar to all of you, most things. You'll say, oh, I recognize and I understand what that probably is. So we'll get to all that. So all the questions about the programming part, that'll be the last segment of the class. We'll talk about all those things to do with the programming. So, and I'll show you where the documentation is. I'll show you where the library documentation is and all those goodies. So those are good questions. Okay, late work. So this is the answer to one of the orientation quiz questions. What's my policy on late work? Is that generally I don't accept late work. In a class where we are highly sequenced, every week we are building on something that we did the week before, and we do that through the course of the entire semester. It's a bad idea to, in my opinion at least, to have a course policy that would not strongly encourage you to stay on track. That said, I do understand that there is real life out there, and sometimes real life appears, and that can interrupt schooling temporarily. So generally I don't accept late work, but if you have something going on that is affecting your ability to complete assignments in the class, then please, as soon as possible, get in touch with me so we can discuss potential solutions. Okay, and then finally, the way the grades are put together. So here's the way. Oh, I forgot about your class. I said wrong numbers. So one quiz, 14. So I forgot that you have a week where I stop all the work later in the semester and just say, let's review everything we've done up to this stage and prepare ourselves for the push to the final project. So you actually only have 16 labs, 16 homeworks, 16 discussions, because there is 1 week in there where I got rid of all that stuff and just say, let's have a review and discussion week. So I keep the best 14 of the 16 weeks of work. Actually, you'll see that when I go back to the course home in Canvas, and then the 2 projects. So here's just to notice the way the points are distributed, where sort of like the bulk of the points are coming from. Okay, so that's the syllabus. That's all that stuff. So let me go back home and just show you, and I should have seen it when I was saying it. So here, the week of November 21st. In fact, I'm going to click on the module to show you that the week of the 21st, which is week 14, only has one thing in it. And it says no homework lab or discussion this week, only lecture, where I will talk about how to maybe get going on project 2. I will do a little bit of review that week. Now that's a long way away. That's November 21st, but that's why I keep the best 14 of your assignments because we have this 1 week, so we only have 16 discussions, 16 homework, 16 labs. Keep the best 14 of each of those kinds of assignments. All right, it is 1:35. Yeah, I'm going to push on because I think I can do this next part in 5 or 10 minutes, and then we will take a break. So let's look through the week 0 module, and then we will take a short break, and then we will do week 1, which is where real content starts to happen. I will show you the programming environment. I'll talk about the language, show you some examples in the language. I happen to like the language okay. I don't use it for anything else, but to me, it's perfectly viable. All right, so let's look at the week 0 module, and then we will take a break, and then we will look at the virtual machine and the programming environment and the HLA language a little bit. Okay, so week 0. Probably most of you at this point have done Canvas courses, but if you haven't, the way I organize my content, which is probably true for most teachers at this point, every week has at least one module. So this week has the orientation module plus the first week module. But if you go to the first document in the module, which for me is always the .0 document. So this is the week 0, which is orientation, .0. And then you can use Canvas to sort of walk through the rest of the module. I'm not going to stop on any of the details here. And I know it's a wall of text and people don't like walls of text, but it's not very many pages and it's not that big a wall of text. So I'm hoping that most of you will choose to at least spend some time scanning through here just to get a little bit about me, a little bit about my thoughts about why I think this course continues to have some value. And a few other ideas about this class. Oh, here's the link to the publisher who publishes the hard copy of our book. I guess I did that as a Easter egg for some reason. All right, so I did the next button. Now I'm on the .1 document. This just talks about how the course is navigated in Canvas. So we have the course navigation links on the left. I know I have some extras that you can't see because I'm in my instructor mode. You'll see all the blue ones at the top. And then it also describes the important links in the gray bar on the left, which include the inbox, which is how you should contact me if you need to contact me one-on-one during the course of the semester. Next button. So this page, another wall of text, but this is just some ideas that I have borrowed mostly from other teachers about what, but also sort of now my own experience about what successful online students tend to do with themselves. So anyway, these are just tips that hopefully you'll take the time to scam. Some ideas, many if not all of them, you probably are already aware of, but things that you might consider that might help you be more successful in an online course. And then I kind of been over this already when we looked at the syllabus, but when you're going through the orientation module, you will get a reminder about how the course works, the kind of activities that you engage in, where the points come from, how I compute the grade at the end of the semester, that kind of stuff. So here's, for example, there are 16, I said 17 before, there are 16 homework assignments, the lowest 2 are dropped, which can include zeros if you just don't do an assignment. Due dates and late work we talked about. Live stream, let me see if this videos page goes to the right place. Okay, they do. Live meetings, broadcasts, and other ways to communicate with me. So again, this orientation module is just stopping and asking you to thoughtfully consider the course policies. Think about what we have ahead of us, which hopefully is mostly interesting and sometimes fun, at least for some of you. This is for people at your stage in your program. You're probably starting to feel your power. I think I said that already. When you sit down at the keyboard, your ability to actually create things on a computer is a very good feeling. And hopefully you're getting to experience that. And hopefully you will experience in this class as you are learning new things. And then finally, the orientation quiz. That's the end of the week 0 module. And then if you click the next from there, it takes you to the beginning of the week 1 module. And so you're at the dot 0 part of week 1. All right, let me look at my agenda and see if I talked about what I meant to talk about. I did. So it is 1:41. This is a good time to take a short break. So I'm going to take a break till 1:45, which would be about 4 minutes, so that I can get up, stretch my legs, refill my water. Hopefully you have a chance to do the same. I'm also going to turn on a ceiling fan because it's hot in here. And we will walk through the week 1 module, and then I will spend some time showing you around the programming environment and the basics of the language that we use in this class. So the questions that were asked about the language, I'll come back to those and make sure those get answered if I didn't already answer them. All right, so 4-minute break. Okay. Yeah. So I'm back. Oh, yeah. Someone. Oh, James. Hey, James. Um, maybe that music was too laid back for this time of day. I don't know. Um, when winter comes, I think I'll be. It won't make me feel sleepy. Anyway, maybe I should switch it out to the upbeat stuff. But anyway, yes, I put together a playlist and I quite like it. Um, okay, so we are uh, back to looking at the week one module, and then we sort of get into what most of us, I think, probably would consider the fun stuff, which is when do I get to sort of um, create things on the screen and in the computer. Uh, so here we go on that part. And then I think when I'm going to have to switch views here in a moment, and I may not have configured that yet. So apologies in advance if I have to sort of clean up my next screen. But let's get there first. Okay, so in a typical module, once you get through with the orientation module, which is a little bit different, a typical weekly module will look like the one that we're about to walk through. So the first page is simply what are we up to this week? What are we doing? What do we expect to learn? So this week we want to, the biggies are to accomplish getting our Piazza account and getting that discussion forum going. And I know that you're probably tired of telling people about yourself. But as far as we know, this is the only place where we will see each other. So sort of assume that we're all meeting each other for the first time, even though I know that's not true for everybody. So apologies about that. I think the discussions do get more interesting for your class as we move past the first week. We want to make sure that we can get the tooling running. So it does require that you install a free piece of software and then a virtual machine. And probably most of you at this point know what a virtual machine is, but a simple way of saying that is that I have created a Linux computer for you to use for this class, and it runs inside of a window on your desktop. And the reason I did that is because, well, I just think it's nice that you encounter Linux at some point along the way. So I'm a fan in that way. But also it allowed me to handle the problem of installing all the necessary software for you and have it just work like you would want it to work. So you can install HLA, high level assembly, which is what this HLA is referring to, on your own computer, just warning that it may be asking you to do things that you haven't done before, like edit your path is the main one, which most of you probably haven't done that kind of thing before. Anyway, so that's why the virtual machine is there. We all get to work in the exact same environment. It looks and feels the exact same to all of us. So on the Mac front, as long as if you have an M1 Mac, then that will require some clever problem solving. If you have an Intel-based Mac, then this all works exactly the same. If you have an M1 Mac, then you'll need to let me know. And I have started to create what I hope is a solution for you for M1 Macs. I sort of fingers crossed that you don't have an M1 Mac or that you have access to something that's not an M1 Mac, because they have complicated our lives in terms of virtual machines. Okay, so anyway, if you have an M1, we can use Piazza. Probably we'll set up a Piazza to discuss your options for dealing with that. Okay, so anyway, the goals for the week is just what's coming up. There is some kind of book style learning going on here, by the way. So defining computer architecture is a matter of reading an article, and I'll talk about it a little bit. Identifying the basic components of the von Neumann processor architecture is also a little bit of book learning. This is kind of just laying in a very simple foundation so that we're all kind of know what it is that the processor is about when we say that and where it came from. So when I write your homework questions, I pick the readings that I want, and then I read them and I write questions out of them. So the answers to the homework questions are contained in the readings because I read them and then I wrote questions directly out of them for your homework. And I'm going to prioritize the programming environment because I'm confident that you can all handle, outside of some introductory remarks, finding those answers by doing these short readings. I do lean on Wikipedia a fair amount for these kind of technical articles. But you'll see that those kind of go away over time, and we spend a lot more time in the book itself, The Art of Assembly. Okay, so this page is the reading and lecture page, and I'll just point out to you that this is the other place where lecture videos appear. So at the end of the live stream today, as I'm exporting a copy to YouTube and I am submitting a copy of the video for captioning, I will embed the caption video on this page, which is one more place where I hope people then don't have to spend much time hunting down the lecture video. It just will show up where they need it to be. Then you have the homework. This is based on the reading. So 10 questions. It's not a lot, so it sort of has to deal with just the biggest issues in the homework. So I'm not going to spend a whole lot of time on this stuff because you're going to read about it and kind of get some of the learning for yourself. But what this class is about is the x86 processor family. So your experience is to learn those things that you do in C++ or Go or JavaScript or whatever language you've used before. What's actually going on in the processor when you write software and cause the computer to execute it. We're trying to gain some insight into how all that works at the level of the processor itself. And then there's a little bit of just fancy terminology to get settled as we get prepared for this semester. So I will just briefly mention some of the key points about processors. So processors, it's just electronic circuitry, and the electronic circuitry is designed to execute instructions. Where do those instructions come from? Engineers sit down and they say, I want a processor that can add, subtract, multiply, and divide. Okay, those will be our instructions. Add, subtract, multiply, and divide. Let's build some tiny circuitry to actually perform those operations. And once they've built the circuitry, now they have, and those instructions, they have a computer architecture. It's simply a set of instructions. That's simply put what we mean when we say a computer architecture is a particular circuit that was designed to execute a particular set of instructions. So if I have Boyd's processor architecture, I might have my favorite 50 instructions on it. And if you make your own processor architecture, you might list a different set of 50 instructions, or maybe you want 100 instructions for your particular application that you want to make a processor for. So I know I'm sort of glancing over this very lightly, but it is useful for a programmer to know that at the end of the day, when I write software, what I'm actually doing is writing something that has to be translated into instructions that a processor that can then execute for me. And we want to know at the level of those instructions, what is the processor actually doing with that? All right, so anyway, that's kind of a quick thumbnail sketch of what a processor architecture is, which is the instructions that were imagined and a processor built to execute them. We have chosen the x86 processor family. I should say I have chosen the x86 processor family, primarily in the case of this class because there is a language, HLA, that allows us to explore the underlying features of the processor while at the same time having access to high-level programming style constructs. And you'll see some of that early on in the semester. So we can actually write the actual processor instructions in our software, and we can also write high-level constructs like if statements around the actual processor instructions, which I find to be a much less painful way of exploring a processor's features. So yeah, there's a question about, are we designing the logic gates? So no, we won't do any logic design or anything like that in this class. Where we as computer scientists start from is an engineer has already chosen their instructions, they've already designed a processor to execute them, and then someone has manufactured a processor. Someone has now made a language and a compiler that translates our instructions for that processor so that it can execute them. So we're way downstream from the logic gates, but it's a good question. So no, we step in kind of after the processor architecture has been designed and after it's been implemented as a processor on a computer. I'm not going to say much about von Neumann architecture. I'll come back to it in the next week or two, but as you're sort of experiencing the idea that there are different processor architectures and different processors built as implementations of those architectures, you'll discover that there are different ways to actually build processors. And von Neumann architecture fits into a particular idea about how do I create the circuitry that becomes a processor. That's, for us computer scientists, a lot of that is shooting largely over our head. But hopefully the readings this week will sort of at least give you a little bit of handle on the basic terminology. So we do the x86 processor in this class. And we do it because we have a language that was designed to allow us to explore the x86 processor specifically. So that's what kind of drives that decision in this class. Someone in chat mentioned the ARM architecture. So we could have done an ARM-based computer architecture course, which is a separate architecture, which means that it is a different set of instructions, which means that it has different hardware implementations. It turns out, by the way, that ARM does not use the von Neumann style of construction. It uses the Harvard style of construction, if you are interested in such things, but that's extra details. So don't get hung up a whole lot in the terminology. I just want you to exit this class with some sense of what we mean when we say processor architecture, and some sense, a very good sense of, now I have a computer with the processor in it, what's it doing? That's our main goal. Okay, so that's your homework 1.2 based on the readings. So here's the part that I want to spend the time on, is the lab assignment, so I can show you and you can get a sense, probably for most of you before you've done it for yourself, of what it's going to feel like to do the programming part of this class. So we encounter new concepts in this class. For example, how and where does a processor store and access data? And very early on in the semester, we will write small programs where we explore what that feels like. So like we will access directly the data banks on the processor itself and view the data that's inside of it. To get a sense of how that's all working underneath our software. Okay, so let's do some lab stuff. I'm going to just review it quickly, and then I'm going to go into the virtual machine and play with it some. So I'm going to do a lot of this from memory once I get over to the other screen. So the whole point of this lab is to make sure that you have had a chance to install the virtual machine software, to install the virtual machine image itself, to boot it up, to log into it, to access the tools that we will use for our programming, and then to actually compile and execute an HLA program. The programming part is going to be sort of disappointingly boring and simple because the goal really is to make sure that all of the tools work. So the instructions say install the programming environment, which includes downloading the Oracle software, and this instructions link leads back to the guide. to download the virtual machine image. So a lot of you, apparently, when you're clicking on this link, weird things are happening. So just don't be a left clicker anymore. Right click the thing. And then you can say save link as, and you can subvert the whole browser effort to open a new tab and all that other junk. Just right click it and save it, and you're done. But there are instructions for doing that. And then testing the programming environment. There is a guide for getting through the first week's assignment, which is really just how do I access all the stuff that I need to do work in this class. And then it will ask you at the end to make a modification of some code that I've already placed in the virtual machine for you. Just so you have the sense of, oh, I've edited the code, I saved it, I compiled it, I executed it. All right, I know how this works. So make sure before you are done that you review the requirements. So occasionally when people are copying and pasting things, they'll leave a line or a character off, and I'm aware of that kind of small stuff. But you should, as your last act, before you call the lab complete, compile it and run it and make sure that it compiles and make sure that it runs and does what you want it to do before you submit it. Make sure that you fill in the documentation, which I'm going to do here in my sample here in just a moment. And then finally, make sure that you do whatever the big points ask you to do, which in this case is to put your name in the running program so that its output shows you and not whatever it currently shows. You do not need to be at all familiar with Linux in this class. So if you've never used Linux before, that's fine. The guides that I created, imagine that you've never used Linux before, and you won't become a Linux expert in this class, but at least you won't be unfamiliar with working in an environment that feels a little bit more manual than you may be used to. But it's not anything to be worried about. You'll see here in just a moment. Okay, so here's the part. I'll just give you a heads up about submitting the lab. So I have you submit the whole code as your assignment. And when you paste your code into Canvas, it's going to destroy all your source code formatting. And I know that, so don't worry about it. It's fine. It's going to take all the tabbing and other stuff. So it's going to look like you've just made a mess of all your code when you paste it into Canvas, but it's okay. I know that happens. And I also expect that at this point in your career, you're in the habit of having nicely formatted source code, and it just Canvas doesn't keep it for you. Okay, so now I'm going to go work on that, which is going to require that I switch views. So let me switch views. And then I'm going to have to do, I think, a little bit of cleaning up here. Probably. Yeah. Okay, so this is the Oracle VM VirtualBox software that you're seeing on the screen. And you'll see that I have a whole bunch of different virtual machines because I also use a whole bunch of them in my Unix class. And then I'm also working on trying to make one for the M1 Mac. This one will not work on the M1 Mac, but I'm in the process of getting one that will. Fingers crossed, I hope. So your environment may just have the one virtual machine, Ubuntu CSCI 10, after you've gone through the steps of installing the Oracle software and installing the image. So once you have all that set up, then you would highlight the virtual machine that you want, and you click the Start button. And now I've already done that so that I could speed us up at this stage of the live stream. So I'm going to bring that in. And then I need to clean it up a little bit because it looks cruddy for you. Okay, that's better. Okay, so here's the virtual machine. Hopefully you get to this point without too much trouble. So this is the machine that I have created for you. And when you sit down to work on the labs in our class, then what you would do, of course, is you would bring up your virtual machine, and then inside of there is where you will do programming work. So here we go. The login, as you will see in the guide, is student. So student. log in. Oh, it just kind of did another goofy thing. So let me make that look better again. Okay. Well, if I'm going to go to the work to have it look nice, it's just going to have to stay that way. All right. So here's our environment. Just to point out to you that the white bars at the top are not the Linux machine. Those are the software inside of which the Linux machine is running. And the white bar at the bottom is also the Oracle software inside of which Linux is running. So everything from this sort of dark gray bar to where the bottom white bar begins is inside of the Linux machine. So this button is kind of like the Windows button. If you click on it, there's stuff in there. So let me just show you how I would go about kind of doing work in this class. So I have made a folder for you for CSCI 10. You don't have to use it, but I thought it might be worthwhile sort of suggesting to you that you keep the stuff organized this way. So there's a template in here, and the purpose of the template is just if you don't know kind of where to start building out a lab or a project, then the template has the basic setup. But I've also given you the full code for the first lab in this folder. So I'm going to go in here. And then what I'm going to do is I'm going to set up the other tools. So the first step, in my opinion, is always to kind of get to where you mean to be storing your files. That's all this is a window that is situated in the folder where I'm storing the Lab 1 code. So we use high-level assembly, which is the language for this class. What's cool about high-level assembly is that it is a high-level programming language that will be very familiar to you, but it also has the ability to let us strip away the high-level components and replace them with processor instructions so that as we go through the course of the semester, our programs look more like assembly language and less like C or C++. And we can do this in a way that we never feel overwhelmed by the transition. So that's the reason why I like this language a lot, is because it lets us do this sort of soft transition from the kind of programming we're accustomed to down to the low-level style of programming that this course is about. So by the end of the semester, very little of the high-level language parts of your programs will be left, and most of what you'll see on the screen will be things that look like assembly language programming, which will be kind of cool when we get there. Okay, so that's all I've done is I've gone to the Lab 1 folder. There's the Lab 1 code. So I'm going to go to the File menu. So I'm going to click on the File menu here. And I'm going to open Terminal here. So this is an important step. It makes the rest of your work session a lot easier. So open Terminal here. Now, if you know Linux, then you know you don't need to do, you can get here however you want. But if you don't know Linux, then this is the way to do it. Get to the folder you want to work in, which in this case is the Lab 1 folder. Go to the File menu, open Terminal here. All right, so now I have a terminal. And I can confirm that the terminal, I'll just kind of wave my mouse over it. The terminal is located on the Lab 1 folder, just like the window is located on the Lab 1 folder. And that's important because it makes the rest of the commands that we issue a lot easier to pull off. So we want that. That's the second step. Get the terminal open in the folder. Confirm that the terminal is, in fact, in the folder that you want. I'm going to go bump up the font size a little bit so you can see better. That didn't do it. What did I miss? I want bigger font. Oh, select. I forgot to select the new bigger font. All right, so now hopefully you can see what I do for the rest of the time better. So we're in the Lab 1 folder in this window and in the terminal, and that's important because the commands that we're going to issue in here are a lot easier if both of those things are open on this location. So this should be a complete program. So I am going to show you a couple of Linux commands. You don't have to memorize these necessarily, but um, you can do a file listing in here. And all that does, so that's ls. So I typed ls and I pressed enter, and all that does is list the contents of that folder. So the contents of the lab1 folder is this one file, lab1.hla, but I already knew that because my window shows that as well. So no big deal there. But if you like working from the command line, that's a useful one to know. So now let's do some HLA stuff. So to compile an HLA program, you type HLA space and then the name of the program. You don't have to put the rest of the file name on here, the .hla part, because the compiler assumes that it will have .hla on it, but you can put the .hla part if you want to. That's up to you. I usually put it so that you, sitting at home, know exactly what I'm doing is I am issuing the HLA compiler command, which is simply HLA, on this HLA source code file, which is lab1.hla. I'm going to press enter. I will notice in the window up here that some new things appeared. A .o file, which is not of any real interest to us, and this lab1 file, which is of interest to us because that's the compiled program that can now be executed. If I want to, I can do the listing again in the terminal, and I will see all those same contents. That this lab1 file is green here means that it is a program. It's an executable program. So that's a good thing. That's what I wanted to get as a consequence of compiling the code. All right, so now we are going to /, which is how you say that, /. It's the slash below your pinky, by the way. It's the easy slash to type. The way I remember, by the way, the slashes, in Windows, they use the slash that's hard to type, which is way up above your pinky. That's the backslash. Everywhere else in the computing world, they use the slash that's easy to type, which is the /. So that's a ./. And then we type the name of the program. So there's no spaces there. /lab1. That's how we execute this program, which is a Hello World program. So most of you probably will be watching this on video later and following along. So of course you can stop and back up and that kind of stuff. So now we have compiled the program by typing HLA space lab1.hla. We have executed the program /lab1 and seen Hello World. So now let's go edit the program and get the result that we want for lab1. So the way I've set this up here is what you'll do to edit the code is you'll type code space dot. If you know your way around Linux, again, you can do this other ways, but I just decided this was going to be easiest for most people to take this approach. So I'm going to say code space dot, and then I'm going to press enter. And what's going to happen is Visual Studio Code is going to open, and it's going to be on my lab1 folder, and it's going to show all the files in this folder. I'm going to stretch this out just a little bit. If I can grab that corner, which I'm struggling to do. There we go. There we go. Okay, so I'm going to click back in the terminal. Once you get all these parts running, there's no need to ever shut any of them down. Yeah, so someone's... a year ago when I taught this class, I was not using VS Code because Microsoft owns it. But I've since used it and felt good about it for some kinds of projects, so I'm switching us over. It also turns out that a student last year created the syntax highlighting for our language, which was super cool. Green Zenith, if you have encountered Green Zenith in a class, Green Zenith made the syntax highlighting for Visual Studio Code for our language for us, which is super cool. Anyway, so when I typed code dot, what that was really saying is open up Visual Studio Code with these files in it. So that's what that was. Yeah, you can use Vim if you want to. It won't syntax highlight, but you can use any editor that you want. I'm using Visual Studio Code because we have syntax highlighting in it, and it's starting to be that everybody is using it. Okay, so don't close any of this stuff. While you're working, just leave it all open. I have the terminal open, and I can just click on the different things and move between them. I can also click on them up here at the top. So terminal, Visual Studio Code, the window for the files. So don't close them. Okay, so the file we want to edit is lab1.hla. So I'm going to click on that. Notice it's all nicely colored for our language. Thank you, Green Zenith. If you ever watch any of these live streams anymore, that's Green Zenith. Oh, Green Zenith is here. Awesome. So anyway, Green Zenith gave me the push over the edge in terms of using it for this class, but I had pretty much moved all of my personal project work into VS Code at this point. Although to be honest, Green Zenith, I'm using Codium, which doesn't have the telemetry. Okay, so here's the program. It's going to be a little bit different at first, but there also should be many things that look fairly familiar to you. Comments, I'm going to go fix that because part of the 10 points of the lab is that I fix the comments. Put my name in here. And put the date in here. Today is 23rd of August. I don't need the gust part. Okay, and then there is a little bit to get familiar with. So one thing I'll tell you right off the bat is that the HLA language does not use curly braces. It does not use curly braces anywhere that I can think of. There's a question about, so no, Visual Studio Codium is an open source Visual Studio Code that has stripped the telemetry, which is the user statistics gathering that Microsoft does. It turns out that by default, Visual Studio Code gathers an enormous amount of data about what you do in their editor, where you copy, where you paste, what you typed, what files you created and saved, and all kinds of other stuff. So the Codium project came to be because some people aren't comfortable with that sort of usage data being sent to Microsoft. I'm not particularly bothered by it, to be honest, but that's why Codium is out there, and I do use it. Anyway, so I did the comments. That's 10 points worth of work. And then just to kind of show you, and I'm going to create another program here in a bit so you can see it built from the ground up. So the way that these things are structured is going to look funny at first, but you'll get used to it. You sort of have this program header at the top, lab 1. Then I have my includes, and when I need them, I will also have variables in this section after the program header. Then this begin and end is how this language does blocks of code. So this is like int main in C++ or func main in Go. Begin and end lab 1 is main, and because this language doesn't use curly braces, this is how it knows where the block begins and where it ends. And then this is simply an output statement. The one thing that may not be familiar with you is this NL. So that's how you do new lines. So that is a new line, in other words, a line break. Okay, so there you go. And the whole lab says I am supposed to put my name in there. Now, all of you kind of know the flow, but I'm going to go ahead and just talk through the flow anyway, just to be absolutely sure. Okay, so this dot up here tells me that I have changes in the file that are not saved. So you can go to the file menu and file save, or you can just Control S, which is what I'm going to do. Control S, the dot went away. That means the changes are saved to disk. So now I'm going to switch over to the terminal, which I could do by clicking on it up here, or I can just click in part of its window. Now I have to repeat the whole process. So I need to recompile. If you have programming, if you have source code errors, you'll get error message at this stage. But since I got no error messages from the compiler, that means it's successfully compiled. And then I can go straight to rerunning it. And there's the hello Boyd, and I have completed lab 1. Some of you probably have just now completed it as well. And this thing, so this code would be copied and pasted into Canvas, and Canvas is going to trash the formatting, and we know that's going to happen, and it's a bummer, but that's just the way that it is. Okay, so I'm going to do a couple more things. What time is it? 2:21? All right, I have a few minutes to just kind of spin up a quick another example just so you can see kind of a setup for like a second lab. I'm going to give you one more Linux command. Technically, it's not a Linux command, but anyway, if you type clear in here and press enter, you can clear the screen, which is nice. Some people like that. Clean up all the garbage off your terminal screen and kind of start with a fresh new screen. Okay, so if I were to work on a new project, this is probably, I mean, if you know better, don't do this. But if you are new to Linux, then let's say that I want to now, okay, I finished lab 1, I'm ready to do lab 2. This is what I would do if I were to work on lab 2 today. I would close the terminal. I would close VS Code. And then I would leave this window open, but I'm going to navigate back to my CSCI 10 folder. I'm going to make a new folder in here, which I should be able to right click in here. Yep. Create folder. I will call it lab 2. One thing you should never do, by the way, just don't invite this complication into your life. Don't put spaces in the names of stuff. So notice that lab 2 is all mushed together. Your life will be so much easier if you just get in this habit when you're working in the virtual machine. Just don't put spaces in file names and don't put spaces in folder names. If you must have a space, then use an underscore. It would be a way to kind of get the look and feel of a space without having a space. But your life will be so much easier if you don't do spaces, so just don't. So I'm going to create a folder for lab 2. I'm going to go into lab 2. And now I'm going to open a terminal here. Now I can see that my terminal is in lab 2. I'm going to open up the editor. I don't have any files yet, but I'm going to go ahead and open up editor, code space dot. Which will also be on lab 2, except for I have no files here yet. So now I can create a new file. There's a whole bunch of different ways to do that. So I can click on this new file link. I can click on this new file link. I can use the menu to get a new file, or I can do Control N, which will also create a new file. I think for now I'm going to use this one. And I'm going to type lab2.hla. So I'm just going straight into the file name that I want. There's no space between lab and 2 because I'm just inviting trouble if I do that. And there's no need for it. So lab2 all smushed together .hla. Press enter. It's going to ask me, so now it's going to ask me to go ahead and create this file since it doesn't exist. I'm going to confirm that it's lab2.hla. I'm going to confirm that it's in the folder lab2, and then I'm going to create the file. All right, so here we go. Visual Studio Code, if you notice here at the bottom, knows that we should be working in the high-level assembly mode. That is because Green Zenith built the extension to do this. All right, so how do I create lab 2? Well, the first thing I should do is put the required comments, which in my class is always the name of the assignment. I usually put a blank line in there. You don't have to. So the name of the assignment, your name, and a date. the date can either be the date you created it or the date that you last changed it, whatever your choice is. But some date that at least kind of anchors it to the time frame where you worked on it is what I'm worried about. So there we go. There is my required documentation. I'm going to go ahead and do a Control S. How am I on time? 5 more minutes max. Okay, but I also wanted you to just see how do I start from a blank screen. So in HLA, the way you set up for a program is you type program and then the name of it. So I use capital letters for the program name. HLA is fine if you use numbers, digits here. So you could say lab 2 and then begin lab 2. That's a semicolon. End lab 2 semicolon. That is the basic structure of a high-level assembly HLA program. I don't like the look of the digits for whatever reason. I just think I just enjoy the word, so I'm putting the word. But you can do either, and HLA is fine with that. All right, so here we are at lab 2. So this section here, begin and end, is where main goes. That's where the instructions that make up the main body of the program, the entry point are. In this section between program and begin is where we do includes. This is where we include or import libraries. It's where we create variables. It's where we actually will create functions eventually and some other things. So for now, to do outputs, we need to include the HLA standard libraries. So this is the only include that we ever need in this class. Some of you might experiment with other includes, but this one basically brings in everything that you need. And we will always use it because it's the way that we will gain access to the output capabilities. So there's my include. I'm not going to do any variables just yet. I'm just going to do some output statements. So standard out.put. This is program 2. I'll put 2 new lines in there. That's NL, not N1, new line. This is program 1, start, and then I will do another one. This is program 2, end. 1 new line after that one, just to kind of show you just a quick little build out. Control S to save. So there's a little program. It's only doing outputs. But again, just so you can kind of see it get built. It does not take any time to get used to the basics of this language. There are a few things, and we'll talk about them, that will kind of catch you out sometimes because you're not used to this language. But it just takes a couple weeks, and then the peculiar things about it you will get used to, and you won't even think about it anymore. All right, so let's go compile it and run it and see if it does those things. So I go back to the terminal. I type HLA lab 2, and I can just press enter now if I want to, but to make it clear on the screen that what I'm doing is compiling that source file, I'm going to go ahead and type the whole thing out. No errors, thankfully. And then I will run it and see if it does what I expected, which is this is a beginning extra blank line. There's the 1 new line, there's the extra new line, and then there's the second statement. So there's sort of a whole setup. There is a guide that walks you through this same process I just did. And that is 229, so that's about time for me to end. What I hope is that most of you have the experience that I believe most people have, which is sometimes it's kind of fun to know that I can use this new language just mostly right out of the gates. Some of the problems are interesting. Often the language, I can take it or leave it, and it's what I'm using it to explore that's interesting. But what I hope that you do find is that the language is not a problem for you. HLA it's just no big deal. Later in the semester, we will do things that if I showed them to you today, you would think I would never be able to do that. But you will be able to do it, and you won't even really think twice about it. You will just do it, in the midst of this huge mess of assembly instructions and not even think it's a big deal. Now it's 2:30. All right, so I am calling it quits. So I did use the whole hour and a half today. Thanks for sticking around for the whole thing, especially since we only had the one break. So office hours on Thursday. There are still some slots if you want to book one-on-one time. You can begin to use Piazza to post your questions, to participate in the discussion. Canvas inbox if you have questions for me. All those channels are good. There's a drop-in office hours on Thursday, and everyone is welcome to be there for as little or as much time as you would like to be there. Talk, ask questions, whatever. So, yeah, that's it. Thanks for being here. I look forward to working with you this semester, and I will see you on Tuesday next week, if not before. So have a good week.